Today we are going to discuss the dimensions of physical quantities from the chapter Units and Measurements. This is very important portion in your exam point of view. So we can study in detail. Today we can find the dimension of physical quantities. So before going to find the dimensions, we have to know how to find the dimensions. Okay. So all physical quantities can be expressed in terms of fundamental quantities or base quantities. We have already studied the base quantities, that is length, mass, time, like that. Okay. So all these quantities we will express as symbols instead of the names. Here, for example, we can see that mass can be expressed as capital M, length as capital L, time as T, like that. Okay. So that all the quantities we can relate with these base quantities or the fundamental quantities. Like that we will find the dimensions of physical quantities. So before defining the physical quantity, we can check one example. Suppose we have area. So here we have to find the dimension of area. So first of all we will write the equation of area, or we can use the unit for finding the dimension. So as this is the first time, we have to know by using the equations how to find this. Okay. So here we have the length into breadth as the area. Okay. So how we can convert this length into breadth into dimensions? So here length, it can be expressed as capital L. Right. Also then breadth we have. So here we can write length itself. Then what about breadth? Can we connect it with any of these quantities? Mass, length or time? Yes, that can be related with length, right? Because breadth is a length itself, isn't it? So how we can write the equation? That will be length into length. That is equal to L square, because this L length can be expressed as L. So we will get it as L square. Is it clear? So that how we can write the dimension of area? Here is there any quantities or any powers for M? No, because there is no mass. And what about time? For time also there is no dimension. So that we can write it as, so always whenever we are writing the dimension, we have to put it in square brackets. So that will be M0, L square, T0. Is it clear? Okay. So that here we can say that the dimension of area is 2 in length. So the dimension of area is 2 in length, then 0 in mass and time. So this power is called the dimension. Here 2 is the dimension of this area, right? Because dimension in length. So how we can define the dimension? That is actually the powers. Okay. So the dimension of a physical quantity are the powers to which the base quantities are raised to represent that physical quantity. Here we can see that this length is the base quantity and it is raised to a power in order to represent a physical quantity, right? So once again I will repeat the statement. The dimension of a physical quantity are the powers to which the base quantities are raised to represent that quantity. Here we can see that in the case of area, 2 in length and 0 in mass and time are the dimensions. Okay, is it clear? So each powers we have to find in the case of a physical quantity. And now we can go to the second example. Here volume. So all these base quantities we should be familiar, because that is a very important question for your board exams. So any dimensions can be asked for exam. So these are the base things. Okay. So don't forget the equations or the dimensions of all these quantities. Here we have volume. Volume, how we can find? Length into breadth into height. That is L cube. That means here we have length, breadth and height. All these are length. Okay. So how we can write? volume is equal to L cube, right? Or easily we can find from the unit. Here the unit is m cube. So what is m? M is meter, right? Meter, that means the unit of length. So directly we can write it as L cube. That is m0 L cube dc. That is the dimension of volume. Now, is it clear? And the next quantity is density. What is the equation for finding density? Density is equal to mass by volume. Right. So, if you are getting the unit also, we can easily find. Suppose we know the unit of density. What is the unit of density? Kilogram per meter cube. Then how we can directly find the dimension? Yes, here kilogram is the unit of mass, right? So what we can write? M raised to 1. Only 1 kilogram is there. So m raised to 1. Then what about meter? Meter is the unit of, yes, length. So L cube by L cube is there. That means L raised to minus 3. L raised to minus 3 and T raised to 0 because there is no time here. Otherwise, we can find the dimension by using the equation. So here how we can find mass by volume, isn't it? So what about mass? Mass is m and volume, that is volume we have already found, right? What is it? L cube, because LBH, that is L cube. So m by L cube, that will be m L raised to minus 3 T raised to 0. So this is the dimension of density. The next quantity is speed. Okay. So what is the equation for finding speed? Yes, that is distance by time. Okay. So how we can relate this distance? Distance is L, right? So time T. So how we can write the dimension? That is m0 L T raised to minus 1. Or we can find it from the unit, right? So how we can find the dimension? That is meter per second is the unit, isn't it? So what will be the dimension of meter? Meter is the distance, right? So that will be L. And what about second? Second is the unit of time. So L by T, the same way. Otherwise we can calculate by using this unit also. Is it clear? Now can we move to the next question? Okay. Here we have velocity. So velocity, what is the equation for finding velocity? It is displacement by time. Right. What is displacement? It is the length, isn't it? So what will come here? Length by time. So what we will get? L by T. That is m0 L T raised to minus 1. So that we can see that here speed and velocity. What is the difference in velocity with speed? Yes, the magnitude is the same, right? So what we are getting? The dimensions are also the same and it has the same unit. Here also we have meter per second, isn't it? So these two are a pair. Speed and velocity are having the same dimension means these are a pair. Okay. And now we can move to the next quantity, that is acceleration. What is acceleration? That is changing velocity by time. Right. So here velocity we have already calculated, that is L T raised to minus 1 by time. So what we will get? Yes, that is m0 L T raised to minus 2, or we have the unit as meter per second square. So it is easy to find from the unit. Right. So what we will get? M is here L we will get, and by second square, that will be T raised to minus 2. So that will be m0 L T raised to minus 2 is the dimension of acceleration. Then the next quantity is acceleration due to gravity. So how we can find acceleration due to gravity? That is also changing velocity by time. Right. So how we can write? The same thing we will get again. That is velocity by time. So that will be L T raised to minus 2. m0 L T raised to minus 2 is the dimension. Now the next one is linear momentum. Yes, what is the equation for finding linear momentum? That is mass into velocity, isn't it? So what will come? Mass is m, then velocity displacement by time, that is L by t. So what will come? M L t raised to minus 1, or we have the unit as kilogram meter per second, that is kilogram m, then meter L, and by second by, that is by t. It will be m L t raised to minus 1. Okay. The next one is force. How we can find the dimension of force? Okay, we have the equation. Force is equal to mass into acceleration, that is ma. Right. So how we can find mass? Means m1. Then what about acceleration? Change in velocity by time. That will be L t raised to minus 2. So total m L t raised to minus 2. So that is the dimension of force. Here the next quantity is work. So what is the equation for finding work? That is force into distance. Okay. So how we can find the dimension? Force is mass into acceleration, that is ml t raised to minus 2 into distance. So L. So what we will get? That will be m into L square t raised to minus 2. Right. Now we have energy, that means all type of energy, kinetic energy, potential energy, and all will be having the dimension of work. So these all are having the same dimension. So sometimes it will be asked to find the quantities having the same dimensions from the brackets, like that. These type of questions are always asked for exams. So we have to remember that which all quantities are having the same dimensions. Okay. So here energy, all types of energies and work are having the same dimension, that is ml square t raised to minus 2. And here we have impulse. How we can find impulse? Yes, that is force into time. Okay, so how we can calculate force into time? So force is mass into acceleration, m L t raised to minus 2 into t. So what we will get? M L t raised to minus 1. Okay. Now pressure. Pressure, how we can find? What is the equation? Yes, that is force by area. So what we will get? M. Force is m L t raised to minus 2 and divided by area, that is L square. Alright. So what we will get? M L raised to minus 1 t raised to minus 2. Okay. Then next one is power. How we can find power? Yes, that is work by time. So work we already know, that is ml square t raised to minus 2 divided by t. So that will be ml square t raised to minus 3. Okay. Now thrust. What is thrust? Yes, thrust is equal to force. So if you are getting these two quantities, that will be a pair. That is, both are having the same dimension. Thrust is actually the force. So we will get the same dimension as that of force. That is m1 L1 t raised to minus 2. Okay. Then stress. Stress is, what is the equation? Yes, force by area. So how we can find? Force is m L t raised to minus 2 by area, that is by L square. So what we will get? Yes, m L raised to minus 1 t raised to minus 2. Okay. And now last one is strain. What is strain? Change dimension by original dimension. So what will happen here? Change in dimension by original dimension. So these two will get cancelled. Right. So is there any dimension for strain? No, there will be no dimension for strain. So such quantities will also be asked for exams. That is dimensionless quantities. So they will not be having any units also. Okay. And for exams, some quantities now we have explained, no? So in that we will find some quantities having the same dimensions. Such quantities I will just tell that momentum and impulse. Here we can see impulse, that is mlt raised to minus 1. So momentum also we have discussed that it has the same dimension. So these two are pairs, that is momentum and impulse. We have to note that quantities also, that is physical quantities having the same dimensions, momentum and impulse. Like that, work, energy, moment of force, then torque and couple. So force constant, surface tension and surface energy. So such quantities are having the same dimensions, that also you have to note for exams. So today I think we can conclude now. Now we can conclude the video. If you like my video, please like, share and subscribe. Thanks for watching.